Look at me, I'm a mess. But it's okay because um, I look like this because of my situation. It's very stressful, okay? I've been working really hard and I think I've found the answer that I've been looking for. So, in logic theory, there's the idea of a proof where you can have such and such premise and it leads to such and such conclusion when you combine it with the parameters. So it's kind of like math. You have variables and operators. So you have A, which is a variable, like a premise, and you say it implies B, or A plus B implies C, or something like that. So I was looking at the definition of matter, and it says that matter is three-dimensional volume. And if you look up the smallest unit of volume, it is a tetrahedron, a Platonic solid, because of the nature of the simplex. So if you apply this to Planck logic, then you will find that each side of the triangle, the 2D mass energy field, that we're just going to use as a premise, is the quantized unit of energy, is going to have a side equal to the length of the smallest unit that we can measure, the smallest unit that we know to exist. They determine that to be P sub L, which is the Planck length. And so you have these sides that are equal to 1 Planck length, and so you have a 1 squared ETU triangle. So if you look at the work of Wayne Roberts, I believe, is who they say is behind the Triangle Manifesto that Richard Blankenship wrote, the logic behind the ETU, the equitriangular unit. You'll find that you can compute a smallest possible area for the volumeless space. And so if we assume that in the second dimension, we have the smallest unit being a triangle, where each angle is 60 degrees and each side is equilateral, then when you extrapolate that into the third dimension, you will find that the tetrahedron is the volume that results from when 4 of these fields combine and then undergo the Evans effect that is described of the bending of light in the Evans photoelectromagneton. So we know that light bends because it curves around planets and such. Gravitational lensing is something that I'm looking into right now related to this subject. But when you have the quantum inductor, the ideal quantum inductor, and it gets joined at the magnetic dipole to create a photon, if you add 2 more T bosons to that and then apply the Evans effect, you will have a closed matter topology. And these are described in Maxwell's equations, and the position of these particles was described in Kelvin Abraham's T122, or I'm sorry, in Kyle Hill's explanation of tetronic theory. He uses a derivative uh, to uh, yeah, uh, d v over d of x or whatever it is. The superposition is explained by the tessellation of these 2D fields and their charge orientation. So each field actually is Lorentz transformable. So each field has four field components, um, which define their behavior. So one is polarized, or I'm sorry, positive 0 point field that turns clockwise, and then you have the other side of the Planck coin, the triangle that rotates anti-clockwise, and it's a perfect ideal quantum inductive loop. Each time you add another piece of energy, the mass increases and therefore the linear momentum increases. When you apply the photomagneton effect, when you bend the light around for example, the divergent field, uh, in that particular example of the um, one he's talking about in 101 at about 15-17 minutes. You got them four fields, and they will bend and form a tetrahedron that has these fascia orientations that interact via the law of interaction. Um, where opposites attract and similars repel. Uh, he describes these fields E equals NHV, H nu. Sorry. And then C squared is the radians for the quantized angular momentum. And I'm sorry, C to the 4 is the radians in the quantized angular momentum of omega that allows you to bend these 2D fields into a 3D topology. And when the tetraons come together at one edge, this is known as the weak force. And then when they come together at faces for all three edges, so face to face, when they encounter an opposite and they connect, that is the strong force. So the weak force operates via the dipole being connected, but they can't come together to form the strong force because they have opposite fascia. But they're still quantum inductively coupled at the dipole. So this not only explains the topology of fields and matter, it explains the nature of their interaction and the formulation of the various subatomic models representing various energy levels and different formations of the result of tau pi interaction and the I still have yet to understand epsilon and mu and the vacuum permittivity and permeability, because you can have a superposition of these fields or these fields. The particles collide and they create more 2D fields. And then you have the radiant photon, which apparently is emitting a bunch of field. And then in the explanation of bar magnet, there's a bunch of fields in a circle. And there's just so many countless different instances of, uh, vocabularies that need to be specifically defined in terms of the frame of reference of tetronics, like electrostatic fields and the radiant photon. Like, I'm still not sure exactly what the radiant photon means. I don't understand how this field could emit other fields as it's moving. So these are studies that I'm going to have to get into. But the point is that I spent a very long time trying to come up with the answer for, what is the universe made of? And now we know it's made of the tetrahedron Platonic solid, as indicated by Pythagoras 2,500 years ago, and he was talking about the spagistration of matter, or spagistration. Anyway, you can combine these fields to form the Z bosons and the W bosons, and then you have the photons, and then you have these other fields that are just massive EM fields. And you can make them, give them as much quanta as you would like in a region of space. I still don't understand the idea of the convergent, divergent vector force and how that works, and the nature of rotation or spin. The convergent forces are Coulomb's law of attraction between charges, which I understand that, I do believe. So it shouldn't be too hard for me to understand divergent, but I just haven't. It'll manifest. The subcomponent of the field is the lesser vector force. So, however many dominant charges there are, so positive charges are more dominant in the field, or negative charges are dominant in the field. If there's less negative charges, then it's going to be a positive field. Obviously. Any equilateral arrangement of energy momenta will always result in a divergent electrostatic charge. I'm guessing that explains gravity somehow. I saw it in a or cosmic expansion. I can't think of it. It's really hard to do this without having people around to talk about it with and have papers out looking. And I need a group of researchers, mathematicians, physicists, cosmologists. We definitely need somebody in logic. We need a computer programmer. We're going to need a graphics designer. We're going to need I need a web developer to help me with the website and all the research. I need a, like a press pass and all that stuff that's in my goals list and in the donate section. We need to be running experiments in order to verify these claims. Because I believe that given the logic of volume and matter, and now that we've established what fields are, and they still call fields particles and stuff like this, it's very interesting. I think I need to modify Wikipedia, start talking about it. Anyway, that's what I'm going to do. So I'm just going to modify Wikipedia. All right, 15-minute video. Have a nice day.